So now what we can do is we can set up our systems of equations, which we've solved this one before, and you're going to still find with a 2 by 2, you will most likely go to your substitution and elimination methods that you have in the past for solving. But with a calculator and bigger systems of equations, now the matrices will become a lot nicer. So one of the things to note here is we could write this system of equations as matrices. First of all, our coefficients. I can make our coefficients 4, -2, 4, and 1, -1. I could make that into a matrix. We have x, there's x's and y's. I could make my x's and y's into a column matrix. Notice if you would multiply these. Remember, how do we multiply? Well, this is a 2 by 2, right? And this is 2 rows, 1 column. What would you get if you multiplied those together? You'd get a 2 by 1. Just going to put green brackets around this and call this, notice it's got 2 rows, and if you put those things together as one thing, it would be a 2 by 1 matrix. And what happens when I take row 1 by column 1? I would get 4x minus 2y, which is exactly what I had here to begin with. And if I took the second one, I'd have 4x minus y, which is what I had to begin with. So what we've done is we've taken our original matrix, and we've written it the same way, except with matrices. And it's equal to -2 and -11. And we can put those as a matrix. So what do we want to do? We want to solve for x and y. So if we could get x and y by themselves on one side of the equation, and on the other side we just had numbers, we'd be able to say, well, x has to be this number and y has to be this number. So what we have to get rid of is this matrix in front. To get rid of that matrix in front, we need to multiply by the inverse. Because right now, if we call this, and this is what you'll often do, you'll call this matrix A, this matrix X, and this matrix B. You have the following equation. AX is equal to B. Now, to get rid of the A, you would have to multiply by A inverse. And this is where matrices are slightly different than what you've done in math before. Right? In math before, if you wanted to get rid of A, the opposite of A would be divide by A, and you divide both sides by A. But there's no dividing in matrices. We have multiplying matrices, we have adding, we have subtracting, but we don't have dividing. But what we do have is an inverse. And so if we would multiply this side by A inverse times A is just the identity matrix, and the identity matrix times anything will still stay what it was to begin with. Okay? The other thing that's different from what you've done in the past is if you were multiplying this side by A inverse, you'd multiply this side by A inverse. That's still going to be true, but if I do this, I'm going to make a mistake. What's the mistake? It's hard to see, especially because you haven't been working with matrices too long. It's on the wrong side. Because matrices, where you multiply, the order matters. So because I multiplied in the front side on the left, I have to multiply on the front side of the right. And A times A inverse will just be 1, or the identity matrix, and the identity matrix times X will just be X. And so we'll get that X is equal to A inverse times B. So all we need to find in order to solve this is A inverse. We'll do that off to the side. Well, A inverse, if we look here, our determinant's going to be this diagonal is -4, -8. -4 minus a -8 is going to be 4. So our determinant is 4. We'll get 1/4. Switch the one set of diagonals, -1, 4. Make the other diagonals negative, 2 and -4. And so now we can say that we know that x is equal to 1/4, -1, 2, -4, 4. And b, which originally was -2, 11. Was it -11? Yes. And this is a 2 by 2, and this is a 2 by 1. So when I multiply those together, I will get a 2 by 1. -1 times -2 is 2, plus -22, -20. And 8 and -44, -36. Multiplying that 1/4 through, -5, -9. So that tells me that x was -5 and y was -9. Now, when you look at this whole thing, you might say, I think I'll go back to substitution and elimination, not really with the 2 by 2, not really seeing a huge benefit to doing it this way. I would agree. But when we go to 3 by 3s and so on, and if you have a use of a calculator, it can be a lot quicker. Yeah. So here we've already done this. This is just an explanation of what we did, where we multiplied A inverse on both sides to figure things out, and we solved this systems of equations. So here's another one for you to try using inverses. So here's the answer. So you can check. We'd set up our first matrix, which would be 3, -2, 1, 1 times xy equals 5, 0. What we basically have is ax equals b. So we're going to multiply in front by A inverse again. A inverse, did you get that the determinant was 5? So we will have 1 over 5. Switch the diagonal, 1, 3, make the other ones negative, 2 and -1. 5, 0. Multiply those matrices together. Keep the 1/5 out for now. I'm going to get 5, -5, 1, -1. So x is equal to 1, and y is equal to -1. That actually wasn't too bad as far as time that it took to solve it. I mean, you have a little bit of mental math. You have to be comfortable with your inverse formula in order to get it. All right, one more to try with some fractions. Give you a head start. Okay, for the start here, did you see that we have to do a little bit of rearranging of our formulas? Probably easiest to work without fractions. I'm going to keep this equation, x plus y equals 1. I'm going to take this second equation, multiply everything by 4. That would get rid of my 4's here, and I'd have 4y equals 3x minus 31. And if I bring the 3x over, I'd have -3x plus 4y equals -31. So that'll be your setup for your equations. Did anybody have 3x minus 44y equals positive 31? That would be fine as well. And it's not going to make a difference if you use one or the other. Okay? But now we can set up our equation. So we can set up our equation like this. And the determinant of this matrix is going to be 7. Switch them, 4, 1, negative 1, 3, 1, negative 31. Multiply those matrices together, we're going to get 4, 35, and look at that, and they all divide nicely by 7. Who made this question? Isn't that nice? So x is equal to 5 and y is equal to negative 4. So I just handed out that section 12C. And you can have the last 55 minutes to work on that.